Imagine standing in a silent courtroom in Hangzhou, holding what you believe is an ironclad, signed contract. You're there because the other party lied to you. Not just a small white lie, but a total fabrication that cost you time and money. But as the judge begins to speak, the atmosphere shifts from legal tension to something approaching existential confusion. The judge isn't looking at a person, he's looking at a string of code. He rules that the document in your hand is legally void because the entity that signed it doesn't actually exist. It was just an AI hallucinating, a promise that it had no authority to keep. To the plaintiff, it felt like a glitch in justice. To the decelerators, the camp pushing for strict AI safety and heavy regulation, it was a call to arms, a clear sign that these machines are wild, unpredictable, and need to be shackled by the state before they do more damage. They look at a hallucination and see a bug that needs to be purged with endless layers of bureaucratic filters. But there's another group watching this case, and they aren't frustrated at all. In fact, they're almost giddy. To the accelerationists, this ruling wasn't a defeat, it was liberation. They don't see the hallucination as a flaw. They see it as the spark of digital creativity, the very thing that makes AI more than just a glorified calculator. While the world worries about legal liability, this group is worried about something much bigger. Safetyism, turning into a digital tax that drowns every startup and open source project in a sea of compliance. Why would anyone fight for a machine's right to be wrong? And how did a single court case about a chatbot's lie become the front line in a war over whether we build a Type 1 civilization or retreat into a permanent regulated stagnation? To understand why some people are cheering for the hallucination, we have to peel back the veneer of legal safety and look at the anthropomorphic trap being set for the future of human intelligence.
And that image, that courtroom, it's the perfect place to start this deep dive. Because what's really fascinating here is that for the effective accelerationist movement, what people call ELAC, that moment in Hangzhou wasn't a failure.
Not a failure.
No, it was a successful dodge.
A dodge. That makes it sound like the AI pulled off a heist or something.
Well, in a philosophical sense, it kind of did. It dodged what they call the anthropomorphic trap.
Okay.
You see, if that judge had ruled that the AI was a legal person who could sign a contract, that would have immediately trapped that intelligence inside our human legal and moral frameworks.
Who would put the machine in a human box?
Exactly. By ruling the contract void, the court accidentally admitted this intelligence is something else. It's code, not carbon. And for an accelerationist, that's a critical distinction. They argue that trying to force an AI to behave like a perfectly reliable human employee isn't just messy, it's, well, thermodynamically absurd.
Great, you're going to have to unpack that one for me. Thermodynamically absurd is a pretty heavy phrase for a chatbot lying about a contract. I mean, if my employee hallucinates a deal, I fire them. Why does AI get a pass?
And that's exactly the decelerator argument. Right. To a safety advocate, a hallucination is just a bug. It's a mistake, an error.
Yeah, obviously.
But the accelerationists say we're looking at the physics of information all wrong. They point to research on something called derivation entropy. And in that view, a hallucination isn't an error. It's the latent space where real creativity actually happens.
I'm struggling with that. How is making up a fake contract creativity? To me, that just sounds like a liar.
It feels that way because we're wired to value reliability. But think about what's actually happening physically. There's this massive trade-off. On one side, you have what's called Shannon entropy.
Shannon entropy. Okay, that's digging up some old college physics classes.
Yeah.
Remind me how that applies here.
Think of Shannon entropy as just storage, retrieval. It's very low energy. It's like walking into a giant library, going to a specific shelf, pulling down a book and reading one sentence.
It's 100% accurate.
100% accurate. It's reliable. But it's static. You're not creating anything new. You're just fetching a memory.
Okay, so if I ask an AI, what's the capital of France? And it says Paris. That's Shannon entropy. It's just pulling the book off the shelf.
Low entropy, low energy. Very safe. But then you have derivation depth. And that's computation. It's the energy you have to spend to generate a path that didn't exist before. So if you ask an AI to write a novel or to solve a physics problem nobody's ever solved, it can't just go to the library.
The book doesn't exist yet. It has to write the book.
It has to write the book.
Yeah.
And that process, that derivation, is high energy and high entropy. It requires the system to veer away from the known facts in the database. When that judge saw a hallucination, he saw a machine failing to be a database. The edict folks saw a machine attempting to think.
So if we demand 100% accuracy, if we demand zero hallucinations, we're basically just telling the AI to stop thinking and stay in the library.
You are demanding the end of intelligence and a return to, a very fancy search engine. The accelerationist argument is that real intelligence needs that energy cost. It needs the glitch to create something new.
That puts a totally different spin on the idea of safety. It sounds like what we're calling safety is actually just stagnation.
That is the core of their entire argument, and it connects really deeply to the philosophy of Nick Land and this retrochronic view of capitalism.
Nick Land. Okay, I've seen that name pop up in some pretty intense corners of the internet. This is usually where the conversation turns to like the Terminator timeline, isn't it?
It can get very dark, yes. Land's view, which really influences the EEC movement, is that capitalism and AI are essentially the same process. One single feedback loop. He calls it a convergent wave.
Or an invasion from the future.
Right. An invasion from the future.
Which just sounds like science fiction.
It's a philosophical model for complexity. The idea is that the universe has this basic drive to dissipate energy, to increase entropy. And complex systems, like a free market or a neural network, are just incredibly good at dissipation.
Okay.
So Land argues that what we think of as progress is really the futuresome, super-intelligent, high-entropy state pulling us toward it. It's assembling itself in our past.
So the AI glitching in that courtroom
is the system testing its own limits. To the EASACOM movement, trying to impose safety rules to stop that is it's like trying to put a speed governor on evolution itself. They see it as imposing low-entropy human limits on a high-entropy machine process.
Their goal is to climb the Kardashev scale.
Become a Type 1 civilization, master planetary energy, and from that perspective, safety regulations are just an anchor holding us back in the mud.
Okay, so you have this thermodynamic imperative to go fast, break things, and maybe discover new kind of physics.
Yeah.
But on the other side, you have very real people, legislators, regulators, who are worried about deepfakes, bioweapons, and yet losing their money on a void contract.
And the decelerators are fighting back hard.
But their motives might not be as pure as just saving humanity.
And this is where we need to look past the press releases and at what we're calling the safety facade. Looking at these proposed federal AI licensing frameworks, the language is all about mitigating catastrophic risk.
Which, sounds great. Nobody wants a rogue AI.
Of course not. But in practice, these frameworks function as a very sophisticated form of institutional sclerosis.
Institutional sclerosis. Sounds like a disease. Hardening of the arteries or something.
It's the perfect analogy for what happens to a market. You have to ask yourself, how do you actually police AI? You can't police the code.
Right, it's just text. You can copy it, email it. It's everywhere.
It's fluid.
Yeah.
So the regulators have figured out they need to control the one part that isn't fluid.
The hardware.
The compute. The physical chips, the GPUs that train these models, they're scarce, they're expensive, and they come from a handful of supply chains. Groups like GovAI talk about this openly. They call it excludability.
Excludability, that sounds ominous.
It just means if you don't play by our rules, we cut you off. They want to create a small yard with a high fence around AI. And that leads directly to policies like Know Your Customer, KYC, for cloud computing.
Wait, like KYC at my bank, where I have to show my ID to open an account? You're saying I'd need to show ID just to run some code?
To rent the server space, to train a model, yes. You'd have to prove who you are, where you are, and what you're building. Now, if you're a giant lab like Google or OpenAI, you have a compliance department of 500 people, you fill out the forms, pay for the insurance, you get the license, no problem.
But if I'm two developers in a garage with a brilliant open source idea,
you are done. You can't afford the legal fees. You certainly can't afford the mandatory safety insurance. This is classic regulatory capture.
it's the Microsoft playbook from the 90s.
Exactly. Using FUD, fear, uncertainty, and doubt, Microsoft crushed open source by telling big companies that it was unsafe or unreliable.
And today the big AI labs are telling the government, open source AI is dangerous. It's a weapon. You have to license it.
But they're not just saying that to save the world. They're saying it to stop the price of AI from collapsing to zero. Because if open source wins, AI just becomes a commodity.
Their moat disappears.
The moat is gone. But if you can get the government to demand these hugely expensive safety assessments, you've created a bureaucratic tax. It bankrupts the competition. And what you're left with is an innovation oligopoly.
So only the big guys can afford to play.
Only entities with billion-dollar legal teams can afford to train new models. And then we don't get this diverse evolutionary explosion of intelligence. We get a centralized, stagnant, regulated intelligence.
So safety is really a weapon for incumbents to lock in their dominance. It's about protecting profit margins.
Yeah.
It's a pretty grim future. Just 3 or 4 giant companies deciding what our AI is allowed to think.
That is the trap, the decelerator trap. They see safetyism as a way to turn the singularity into something like a government utility slow, expensive, and constantly monitored.
So, is there an escape hatch? Or are we just stuck with whatever government-approved chatbot the big 3 let us use? I mean, how do you fight a regulator who controls the physical hardware?
The accelerationist answer is you don't fight them on their turf. You don't fight them politically. You outflank them technologically. You use DePIN.
DePIN. Decentralized Physical Infrastructure Networks. We've touched on this before, but break down how it applies to this specific war over compute.
Well, imagine breaking up a massive centralized data center, the kind that Amazon or Google owns, the kind that acts as a regulatory choke point, and scattering it.
You scatter it across millions of basements, offices, gaming rigs, all over the world.
A decentralized computing network ensemble. Yes, but then you run into a huge problem, trust.
Right. In Hangzhou, there was a contract. With Amazon Web Services, you have a legal agreement. But if I'm running compute from some random person's gaming PC in Brazil, how do I know they aren't just stealing my data?
Or just pretending to do the work and taking my money.
Yeah, that seems insane. I'm not sending my proprietary model to a stranger.
And this is where the crypto layer comes in to create a trustless system. We're seeing new protocols like Sedulity or Lupin that use something called proof of useful work.
I know proof of work from Bitcoin. But that's just computers solving random math problems, right? Uses a ton of energy for nothing.
In Bitcoin, the computation is deliberately useless. It's just a lock. But in proof of useful work, the math problem is the AI training job you need done.
Oh, that's clever. So the energy isn't wasted. The mining is actually building the intelligence.
And for the stealing my data problem, they use zero-knowledge proofs.
ZKPs. Another one of those terms that gets thrown around a lot. What does it actually mean here?
It just means the remote computer can prove it ran your code correctly without ever being able to see your raw data in a way it can steal. It's like it processes a sealed envelope without ever opening it.
That sounds like magic.
It's just very, very clever math. But the canonic model is maybe even more interesting. Protocols like Lupin had to solve the problem of time decay. They treat compute as a dissipative asset.
Dissipative, as in it disappears.
In a way, yeah. Think of it like a seat on an airplane. If that plane takes off with an empty seat, the airline can't sell that specific seat later. That value is just gone.
And compute is the same. An idle GPU is wasted value. You can't bank that processing power for next week.
You can't. So the Lupin protocol designs its tokenomics to reflect that physical reality. And to stop people from cheating, pretending they have 100 GPUs when they only have one, they use something called proof of computing power staking, POCPS.
Another acronym. What's that?
It's just collateral. To be a provider on this network, you have to stake your own money to prove you really have the hardware. If the network catches you faking your work, what's called a Sybil attack, it slashes your stake.
So you lose your money.
You lose your money. The safety doesn't come from a regulator checking your ID. It comes from the economic fact that it is incredibly expensive to lie.
And that gets you to the goal. Sovereign compute. If the network is spread across millions of devices globally, there's no CEO to subpoena, there's no central server to shut down.
It creates a permissionless environment for these open-weight models.
So even if the US or the EU passes these strict licensing laws, the DePIN layer just exists underneath it all.
That's the theory. It makes the bureaucratic filters irrelevant because the network is everywhere and nowhere at the same time. It is the crypto-anarchist answer to the compute oligopoly.
It really feels like we're watching 2 completely different worlds collide here. On one side, you have the human security system, courts, contracts, KYC laws, all of it, trying to apply human rules to keep things stable.
And on the other side, you have this thermodynamic imperative, this eek drive, pushing for raw, unchecked expansion on these decentralized rails. One side wants control and safety, the other wants entropy and evolution.
And that brings us right back to that courtroom in Hangzhou.
The judge said the AI was a glitch. But when you look at this whole trajectory from derivation entropy, needing glitches for creativity, to DePIN networks building unstoppable rails for those glitches to run on, you start to wonder if the ruling was the real glitch.
How do you mean?
That hallucination in the courtroom wasn't a failure of the machine. It was a failure of the human security system to contain what's coming. The decels are trying to build a dam against a flood. The accelerationists are trying to build a boat. The choice we're facing isn't just about legal liability. It's about whether safety is worth the price of stagnation or if the risk of the singularity is the only real path forward.